Alright, hello everybody. Welcome to this, how it works video. So I'd assume if you're watching this video about radial solenoid engine, you've seen some of the other ones on YouTube. So mine's fundamentally not very different. So let's first of all just go over each individual part. I've brought along my very first solenoid engine, at least the first one that worked, and oh my cat. Anyways, so yeah, you can see what we have here is we have a coil of copper wire. This coil is what creates an electromagnetic field. It just basically turns into a magnet when you run current through it. And what that does is that attracts this iron rod. So if you can imagine this turning, so right now you can see that this rod is kind of in the up position. If we were to turn this electromagnet on, this iron rod would be pulled inside like this, and it would turn. Right, and then after it had enough momentum to get past that a little, this one would turn on, oops, right here, and pull it, right? And then this here is the, I don't know if you call it the commutator or whatever, but this would be powered, and you can see that right now, so look at this one right here. This one gets powered, and this wire is going to this solenoid, and you can see that the timing's a little off because this thing actually won't even work right now because it's kind of been abused and the alignment's really off, but you can see that now this one will get turned on and it will pull. That's kind of weird, they're both on at the same time. Like I said, this is just a prototype, but yeah, you get the basic idea. So this one, it's not too different. Let's move the camera over a little bit just so I can get in there to show you guys. Of course the tripod's all stuck now. Alright. So I'm going to zoom in a little. So again, we've got the coils. These ones a little neater, but we've also got a much different design. In the description, I'm going to send you a link to it's a Wikipedia video, I guess, where you can really see in detail how this mechanism works. But it's really pretty simple. Right here, I have a fixed rod. So this circle washer and this rod are stuck together. All these other ones, let's zoom in a little more. All these other ones can sort of freely move, but this one is really stuck. And you'll see that, you see these pivoting right here. But this one does not pivot as it turns around. And with engine where the action is, or I guess like the power stroke is when it's pulling, which is not like a gasoline engine where your power stroke is the explosion and it pushes. You don't need that. Doing it this way makes the engine a lot easier to build because there's a lot of things you don't have to worry about. But it's a fixed rod because it doesn't make a difference either way. So yeah, these are iron rods, these are copper coils. Everything else here is aluminum, except these brackets, this middle piece. Now even this counterweight here is aluminum, and I know what you're saying to yourself, aluminum doesn't weigh anything, why are you using aluminum? To be honest, it should be iron, and it should be a little bigger. But I don't have a bandsaw, so I'm pretty pretty surprised I was able to cut that out. Yeah. Anyways, so yeah, this is not balanced at all. What you've got to do is, you can see I probably got a little different angle zoomed in. My cat's tearing up my couch. So anyways, we have this rotating right here. A 1/2 inch over this way is where the center rod is, if you see that in there. Right. So that center rod down here doesn't move, but this sort of orbits around it. What was I gonna say? Oh yeah, so anyways, everything on this side of that orbit, all this weight needs to be counterweighted by this thing. And if it was built to the spec that I designed it to, which would mean being on iron and being bigger, it probably would have counterweighted the weight at least a little more than it is. Anyways, I know this is not why all of you are here to see the video. You're here to see how I switch the solenoids. So originally, underneath here, I built something a little bit like this. I had a sort of a 1-inch copper pipe, or maybe a 3/4 inch. Yeah, it was a 3/4 inch copper pipe, and I had a 3/4 inch wooden dowel in the middle of it. It was only about maybe a 1/2 inch thick, and that had a notch cut in it. A lot. It was honestly the same exact thing as this here. So part of it was solid, and part of it had a notch cut out of it. So if you look at the design here, we want to be turning these solenoids on when they should be pulling. And the way you can tell when they should be pulling, let's rotate this. So watch this solenoid right here. I'm going to zoom in even a little more. You can see if it was trying to pull right now, basically what it needs to do is it needs to make a straight line from here to the center spinning thing right to the outer one, or to like the, man, I'm not a engineer. Like, I've never taken a class in this, so I don't know the names. Anyways, yeah, anyways, just here's a simple way to say it. You can see if I was to pull it right now, it would be a lot easier to pull it backwards this way, and that would be bad. So you wait until it's gotten past that, and then when it pulls, well, if it wasn't so stiff. There. So that's what we've got to get the timing as. And you'll notice, let's see, where's the, okay, so this one's done pulling. This one can still pull, this one can still pull, this one can still pull, and this one is just about ready to pull. In fact, now it's ready to pull. So at maximum there's 4 on at a time, but more often than not there's only 3 on at a time. So that means I'd have to, well, basically, instead of, you know, cutting this in half, right here, let it focus, I just have to make this a little bit less than half, and it would work. The problem was, this works alright with 3 wires touching it, but this one does not work very well with 8 or 9 wires touching it. So I came up with, and here's the big tease I've been putting off the whole video. That. So I'm sure a lot of you are saying, yep, that's how I did it, that's what I thought. Or you're actually somewhat impressed. So I have 8 push buttons here, and I have a washer that you can see it's not quite at the half mark. So if it was cut at half, it would be a little bit bigger, but it's a little shorter. So this one really only pushes, you see how it can never push 4 at a time as it rotates, but it's really only pushing 3 at a time because it's such a short amount of time. Anyways, I've got to sort of wrap up this video. My camera is about to die. But yeah, each one of these switches go to a solenoid, and they're all evenly spaced. So as this spins around and pushes the buttons, like right now this button's pushed, and this wire is going to this solenoid. So, what do you know? That one is just ready to turn on. And that turns on and gets it pulling. And that was all out of frame. Sorry about that. Right, so let me reset that. Alright, so this button right there has just been pushed. So if we flip that around to the corresponding solenoid, which is this one, you can see that if this solenoid was to turn on, it would pull it down. So it's real simple. And then I've got a really nice 18 volt battery to power this. So anyways, oh, and there's no flywheel on here. I took it off because it covers up all the mechanism under there. So anyways, let's see if it actually works. That's right, it works even without a flywheel. And if you notice in the video, it starts up slow and then it gains speed. That's putting energy into the flywheel. With this one, starts right up. Anyways, I don't know if I want to say this yet, but I am making another one of these, another radial solenoid engine. But I'm doing something that no one has ever done before, which is gonna remain a secret until future videos, because I'm not quite sure if it's gonna work, but it probably will work. Yeah, so anyways, thanks for watching, guys, and see you guys in the next video.